Chapter 14, Simple Linear Regression. Simple linear regression is about a variable called dependent variable, and we use the notation y, and the dependent variable is the variable whose value we want to predict using what is called a regression equation. And to predict the value of y, we use another variable x, and we call that variable independent variable. So it is the independent variable x that is used to predict the value of y. So the variable x is what is doing the predicting or explaining the value of y. Y is the variable whose value we want to predict. So for example, y can be sales and x can be the price per unit that we charge for the product. So depending upon what price we charge, we want to be able to predict what the sales will be. And we want to do this using simple linear regression. So simple linear regression is a relationship between these two variables x and y that is approximated by a straight line. And a straight line relationship between x and y is what is called simple linear regression. And the regression model will look like this. So y, the value that we want to predict, is a y-intercept beta sub 0 plus slope beta sub 1 times the value of x, the independent variable, plus an error term. If y can be exactly predicted with the value of x, then we don't really need statistical analysis, but there is some amount of randomness in the value of y, and that randomness is captured by the error term epsilon. Then we define the expected value of y, or in other words, mu of y, or the average of y, as you drop the error term, so you get beta sub 0 plus beta sub 1 x. So this is called the regression equation. So this is the mean of y for a given value of x. Then the estimated regression equation is given by this formula, y hat, and that is the estimated value of y. It is b sub 0, which is an estimate of the beta sub 0, and b sub 1 is an estimate of beta sub 1 times x. So if a value of x is given, say if x is 10, then we plug in 10, and if we know the value of b sub 0 and b sub 1, then we can calculate what y hat will be for x equal to 10. So y hat is the estimated value of y, and this line is often called a fitted line. So let's look at an example at this point. Now this example is from your textbook. Here, to illustrate the regression equation, let us assume that we have a pizza company and they have pizza restaurants near college campuses. So now they want to estimate what the quarterly sales of pizza will be based on the population, student population in the campuses. So quarterly sales is what we want to predict, and that is our y. And we want to predict that using the value of the student population. So student population is x. So then we can write an equation y is equal to beta sub 0 plus beta sub 1 x plus error term epsilon, where y is quarterly sales and x is student population. Once we have the model, then we want to estimate the intercept with b sub 0, and we want to estimate slope beta sub 1 with b sub 1. And in order to come up with this estimate, we have to take a sample of x and y values. So in the example that we just looked at, we can take a look at a sample of college campuses and collect information about X and Y. So in this example, let us assume that a random sample of 10 campuses were selected, and in each of those restaurants, what is the student population in thousands? That's our X. And what is the quarterly sales in $1,000? And that's our Y. So we have a sample of 10 observations, and for each observation we have a value of X and a value of Y, and using this sample we want to estimate the value of the y-intercept and the value of the slope, and these estimates are b sub 0 and b sub 1. And the way we want to come up with these estimates b sub 0 and b sub 1 is called least squares estimate. And the least squares estimate follows this logic. So let's say y sub I is the ith observation of the response variable, which is y. In our example, it will be the pizza sales, quarterly sales. And y hat sub I is the estimated value of quarterly sales for x sub I, the x value for the ith observation. Now, since this is going to be not exactly equal to y sub I, there will be a statistical error, and that error is often called residual also. And the error is y sub I minus y hat sub I. In other words, y sub I minus that part. Now, this error term, if you square that error term and add them up, that will be your total estimate of the error, which is called sum of squares due to error. Now, the least squares method attempts to find formulas for b sub 0 and b sub 1 that will minimize the value of this sum of squares of error. And that's why this is called least squares method. The b sub 0 and b sub 1 values minimize the total of this sum SSE. And that formula is given by b sub 1 is that, or it could be this. Okay, they both are exactly identical in terms of the result. They're just written in a different way. And b sub 0 is given by this formula. So these two formulas are called least squares estimate, because if you find the value of b sub 1 and b sub 0 in this fashion, the sum of squares due to error, SSE, is guaranteed to be the minimum possible value. Now, these formulas are already available to us as Excel functions: slope for b sub 1 and intercept for b sub 0. And each of these two functions require the y range, comma, x range as the arguments. So now let's look at an Excel example. We'll calculate b sub 1 and b sub 0 for the pizza parlor example.